Pinarello has just presented the bike that Filippo Ganna will ride in his hugely hyped attempt to break the hour record. The Bolide FHR 3D is entirely 3D printed and is the identical frame that Dan Bigham used to claim the current hour record just over a month ago. Keep watching for more on Ganna's latest ace in the hole. Firstly, are we entering a new era of design? In terms of aerial bike frame design, Pinarello has a long history of breaking new ground. The Espada for Miguel Indurain came first, followed by the Peregrina for Andrea Colinelli, Italy's 1996 Olympic gold medalist, and more recently, the original Bolide HR for Bradley Wiggins' successful hour record attempt in 2015. With a 3D printed aeroframe that is apparently the first of its kind, the Italian manufacturer now appears to have pushed that frontier even further. Pinarello has already experimented with 3D printing and the hour record. The handlebars Bradley Wiggins used for his victorious hour in 2015 were created by the Italian manufacturer in collaboration with an English company called Metron. Pinarello and Metron have teamed up once more to 3D print the entire frame, fork, and cockpit for the new hour record bike. Next up, aerospace technology. Scalmalloy is an aerospace material made exclusively for 3D printing and is apparently used to build the new bike. It is a high-strength scandium aluminum magnesium alloy that Metron is well familiar with because it was used in their Mythos Elix 3D printed stem. It shouldn't come as a surprise that Pinarello chose aerodynamics as a crucial consideration while developing a new frame. The company also noted that comfort and sturdiness were essential elements of the ideal track bike, which is where 3D printing comes into play. The engineers at Pinarello set out to combine strength, stiffness, and comfort with aerodynamic benefits on the new Bolide HR. The objective was to develop a package that achieved these goals in a frame with precise millimeter dimensions. Pinarello turned to 3D printing since the current carbon fiber manufacturing methods could not produce such a precise and innovative design. The front triangle of the 3D printed frame comprises 3 Scalmalloy sections, while the seat stays and chain stays make up the remaining 2. Then, aerospace-grade epoxy is used to join these separate components. Don't be fooled if this makes the procedure seem simple, it certainly isn't. Moving on to research and development into the Bolide. For hobbyist 3D printers, trial and error is a familiar cycle, but a bicycle frame and a world record attempt left Pinarello with no room for error. Metron has a lot of experience in 3D printing cycling parts. To make sure there was no room for error, the two brands sent the new bike to a reputable lab for mechanical testing of bicycles, e-bikes, and components for a variety of fatigue, impact, and torsion tests. The new Bolide HR passed those tests and is believed to be the first fully rideable 3D printed UCI-compliant bicycle to meet ISO 4210 requirements. They have been able to incorporate new features and shapes thanks to 3D printing that are simply not possible to recreate with the current carbon fiber techniques. Federico Spriza, chief marketing officer of Pinarello, went on to say that what they created is such a unique concept that it's going to be the start of a new manufacturing era. The next move will be to lower the cost by figuring out how to scan riders using less expensive technology and automatically create each individual bike. Eventually, every cyclist on the road and every World Tour rider is expected to be riding 3D printed bikes. Don't expect to be printing frames in your garage anytime soon, even though Pinarello may have created the first 3D printed frame. It makes sense that the selection of the material and the equipment is important, and that's why Metron chose a Scalmalloy alloy and an electron beam melting printer for high-stress sections like the fork head and the handlebar extensions. On top of that, they are strengthened with titanium. So yeah, we can't just be casually printing these at home. More on humpback whales. Putting manufacturing methods aside, the new Bolide might be efficient to meet Pinarello's goal of regaining the hour record. Bigham took extra care not to reveal any information about the new seat post and seat tube. Today, Pinarello finally gave some information on the alleged advantages of their remarkable design. The constant up and down movement of a rider's legs is a key factor in the alternating airflow on the seat tube and the seat post. This alternating airflow is thought to produce low pressure regions around the seat tube that increase drag. Pinarello cites a drag distribution map that it has produced to argue that a part of the reason the combined drag of the seat tube and the seat post is so high is the difficulties the airflow has in actually adhering to the seat tube. So, what solves a weak seat post? According to Pinarello, the solution is found in humpback whales. Despite their size, humpback whales can make extremely precise turns and breathtaking leaps out of the water. The protrusions on the humpback front flippers, according to researchers in Adelaide, greatly contribute to this seemingly physics-defying skill. This helped the water stay anchored to the whale's fins, tail, and flipper. However, Pinarello said it's too soon for us to run out and cover our seat tubes in tubular tape, saying that simply placing a few bumps on the front seat of the tube is not enough to make anyone quicker. They should certainly know. Pinarello resorted to its aerodynamic R&D partner, Noblaflow, to enhance the speed bump's aerodynamic benefits. It finally settled on a specific design known as aeronodes, which is supposed to fully use the new technology. Next, alien-looking handlebars. Filippo Ganna has been wearing an odd-looking, futuristic aero extension with an elbow-like bend in their riser part all season. Frequently, we thought that this might be some kind of wave-generating device meant to produce a low pressure area for Ganna's legs to spin around in. Even though they have revealed no secrets yet, Pinarello has finally revealed some of the information behind Ganna with the release of the Bolide HR today. Pinarello was quick to emphasize that although some components may be slower than other faster alternatives, the most crucial factor is a component's capacity to lessen the drag on the entire bike and rider system. One such element that was created especially to lessen system drag is the redesigned handlebars. The handlebar geometry was developed to lessen the rider's drag more than the drag penalty given by its weird design. Let's talk more on that innovative design. We shouldn't only give credit to humpback whales and 3D printers for the new Bolide design. Pinarello said that significant advantages were gained because of the redesigned frame's smaller frontal area. So, how narrow is it exactly? According to Pinarello, the frame's button bracket width is only 54 millimeters, reduced from 70 millimeters. Now, the front and rear wheel hubs are only 69 and 89 millimeters wide. Naturally, narrower wheels are necessary for a narrow frame, and that is where Princeton Carbon Works comes in with its double disc design. More information about Princeton's new track-specific disc wheels will be released soon, but it is safe to say that the ultra-narrow front and rear disc wheels are an intriguing addition to the bike. The elimination of the 3:1 ratio also allowed Pinarello to design deeper and thinner tube profiles across the frame, which are known to offer considerable aerodynamic advantages over tubes subject to the previous 3:1 ratio. One of the most remarkable features of the new design is its narrow forks. Pinarello considered a variety of fork and seat designs, both narrow and broad, before deciding on the wheel-hugging design that we see today. However, they said that the results were too unstable, and the potential improvements were not consistent enough to adopt such a design. But despite that, the wide-set forks like those used on the Hope Lotus GB track bike are expected to offer significant gains. Finally, have we achieved peak aerodynamics? This collaboration allowed Pinarello and Nabla Flow to use the Aero Cloud online software, which is an automated high-performance computing-based CFD analysis platform. It offers external aerodynamic simulations to do their aero simulations and CFD analyses. One may assume Pinarello has reached peak aerodynamics, considering how the company appears to have blended 3D printing, natural design, innovative technology, and some of the top aero minds in the industry. Well, it seems not. According to Pinarello, even though they analyze and document the individual drag contributions made by the bike and rider, the secret is how you mix these elements together and how you decide what the next stages should be. Pinarello and Metron say that advancements are constantly being made despite having worked together for 10 years to perfect their secret design. They believe that we are still nowhere near peak efficiency. If Ganna succeeds, 2-hour records with 2 different riders in less than 2 months would unquestionably mark a new high point in Pinarello's legendary hour record history and serve as the sole necessary proof of the new bike's performance and aerodynamic capabilities. And that's a wrap for this video, and thanks for watching. What did you think of the new 3D printed Bolide, and what will it mean for Ganna? Let us know in the comments below, and make sure to give this video a thumbs up and subscribe to our channel for more videos just like this. We'll see you in the next one.